everyone, I am Ruchi Jain, Assistant Professor from Department of Information Technology of ABES Engineering College, Ghaziabad. Today I'll discuss about software testing. So, what do you mean by software testing? Somehow everyone says that software testing is a process of executing a program to prove that it works properly. But this definition is an unacceptable definition because if a if a particular software works properly, that does not mean it is a bug free. So here is an acceptable or real definition of testing is a process of exercising a program with the specific intent of finding errors prior to delivery to the users, which means that we have to test a particular program or particular software to that extent or with particular intention that it should be bug free or error free before delivering that to the end user or to the client. So there is a primary axiom for testing equation which says that a test when executed that reveal a problem in the software is a success, which means that it is a job of particular software tester that it should test a particular software, and it should be a target of that particular tester is that he or she has to find bug or error in that particular software. If a tester find or if a tester becomes successful to find an error or bug in a software, then you can say that his job is done. So here again our question arises that who tests the software? So the software can be tested by two types of people. One is software developer and second is independent tester. So here a question arises how they both are different and how their jobs are different with each other. Software developers are test their software which they develop by their own. That means that software developers understand their system very well, due to which they test their software in a very gentle mode. So and they are very driven for their delivery. But independent testers are the third party testers which must learn about the system, and they have to find each and every bug from that particular software, and their focus is on the quality of that particular product. Here are various components of software development process which are PDCA. PDCA. P stands for plan, D stands for do, C stands for check, A stands for act. As you can see that P stands for plan. Plan means devise a plan, or you have to create a plan according to the need of the client. For devising a plan, you have to define an objective and determine the strategies and supporting methods required to achieve that object. Planning of particular software or planning of particular module should be done in an effective manner, because if any of the objective get missed from that planning strategy, then the overall outcome of that particular software is not up to the mark or according to the client. D stands for do. Do means executing the plan. This means that the plan that has been devised in the first step, you need to create the environment or conditions and perform the necessary condition to execute that plan. Execution of plan is totally depends on the planning of that particular software or particular module. C stands for check. Check means check the results. After executing the plan according to the objective of the particular software, you have to check its result, whether work is progressive according to the plan or whether the expected results are obtaining. If There is any error or any bug occur during the checking of that particular software, then you have to do the necessary action. A stands for act, taking the necessary action. If the checkup reveals that work is not being performed according to the plan or that results are what are anticipated, devise measures for appropriate actions. This means that after checking the results of the software that were executed or developed by the software engineer, the software developer, software tester need to check in this phase, and after checking if there is error occur or any bug occur, then we have to do necessary action by performing fixation process on that particular error or bug. Here is a software testing life cycle. As you can see that there are four basic phases of software development life cycle: soft requirement specification, design, coding, testing. As you know that requirement specification is a phase in which we plan what we need to execute, what we need to develop according to the objective of the client. So requirement specification is done in a very proper manner. If there is an error occur in requirement specification, then it get propagated in the later stages. Designing is a designing the prototype for the particular software on the basis of the requirement specification done in this phase. If there is error occur in designing phase, then that prototype get designed with bug or with error. So if we code that bugged prototype, then it can't be worked as per the client requirement. Coding is a development part of the prototype that designed in designing phase. Here as you see that there is error fault in each and every phase, so we have to find error or bug in every phase, because if that bug or error is not rectified in earlier stages, then it get propagated in the later stages, which causes for if expenses to which causes expensive to rectify it in later stages. As you can see in the right side, and in testing there are three phases: fault classification, fault isolation, and fault resolution. Fault classification means after testing the various stages of the software, we have to classify which type of fault is it, whether it is a simple fault, where it is a fault which causes for majorly action, and so on. Fault isolation means we have to check that that particular fault is causing effect on which part of the software. Fault resolution: after isolation you have to resolve that fault, or you have to fix that fault so that particular software or module get bug free or error free. Next, there is software testing principles. What are the various testing principles are? The following are the various testing principles. First is all tests should be traceable to customer requirement, which means that your test cases should be made in such a way that it traceable or the customer requirement. For example, if we are planning to execute, we are planning to create an embedded system for ATM machine. So what are the test cases for that particular ATM machine is that here is an example of one test case, like there that it should not accept any input requirement of amount of money in other than multiple of 100. Or second, test should be planned long before testing begins. Third, Pareto principle: 80% of error occur in 20% of program, which means that if there is higher error in lesser amount of program, that program should be redesigned or re-implemented. Testing should begin in the small and progress towards testing in the large. This means that you have to test the program in a small modules. That modules get integrated in a larger module. That larger module is again tested, and these larger modules are integrated into larger program, and that program is again tested. Exhaustive testing is not possible, which means that we cannot test our program in an exhaustive testing. Means you cannot create lakhs or crores of test cases for a particular software. So we cannot test each and every test case for a particular software. To be more effective, testing should be done by independent third party. As I have already say you or explain you ki if we adopt independent third party testing, then that testing is unbiased, and unbiasing testing gives you a well structured, well executed software with bug free environment. Next, there are some software testing myths which are as follows. We can test a program completely. As I have already explained you that we have to test small modules which get integrated into a larger module. Second myth is we can find all program errors as long as test engineers do a good job. It is again a myth, because there sometimes a condition occur that we have find various errors, we have rectified these errors, but sometimes at the runtime some error can also occur at the client side. We can test a program by trying all possible inputs and states of the program. Again, it is a myth, because we cannot do exhaustive testing in software testing lifecycle. Good test cases always a complicated one. This is again a myth, because sometimes simpler test cases also give error from the particular software, and these are also sometimes beneficial for a software. Next, software testing automation can replace test engineers to perform good software testing. It is again also a myth, because software testing or test automation can be done in a software where we have to do same thing multiple times. But if we got a new module, then we have to perform manual testing on that particular software. Software testing is simple and easy. Anyone can do, no training is needed. This is again a myth, because software testers need to train in a particular software, in particular language, because as I have already mentioned you that independent testers are also need to understand the system. They have also good knowledge about the coding, and they also have a good knowledge about the software. Those who are having that well trained or have good knowledge, they only can do the software testing. So this is again a myth. These are the various references of software testing: Yogesh Singh, software testing; KK Agarwal, Pressman, software engineering practitionering approach. This is a disclaimer: all content, images and graphics used in this video belong to their respective owner, and we or this channel do not claim any right over them. Thank you.